Okie doke, so we're going to look at this limiting reactant issue in the real world level, so to speak, with using grams, because that's what we're going to be doing in lab, weighing out reactants, weighing out our products. And as it says there on the back of your notes packet, once we know the limiting reactant, we can calculate the theoretical yield for a reaction, and then we can run the reaction and we can see how well it goes by comparing our actual yield to our theoretical yield, which is what the percentage yield is. So here's this problem. I just plucked it from your book, and it's asking you to determine the limiting reactant, theoretical yield, and the percentage yield. And we're going to be using our recipe for making ammonia. We see the balanced equation there. And it says I've got 14 grams of nitrogen mixed with 9 grams of hydrogen. And when this happens, 16.1 grams of ammonia, NH3, form. Well, as your book shows you, gathering of your information and planning your work, I'm sure you don't go through this detail to solve every problem, even though you should. But as you see my big arrow on the right-hand side there, it says we need to do two mass-mass problems. And essentially what the two mass-mass problems are asking us to do is figure out how much ammonia can you make from each of the reactants. So you can see, starting with my 14 grams of nitrogen, if I do the mass-mass problem, it tells me I can make 17 grams of ammonia. Well, if I start with my 9 grams of hydrogen, and I do the mass-mass problem, it says I can make 51 grams of ammonia. So even though it looks like I only have 9 grams of hydrogen and 14 grams of nitrogen, and you'd say, well, there's less hydrogen, but because of the recipe and the molar mass and all that stuff, we actually end up showing that we can form less ammonia with the nitrogen than we can with the hydrogen. And so because of that, our nitrogen is the limiting reactant. Because you're going to play mixy-mixy with the nitrogen and hydrogen, and it's going to make ammonia until you get to 17 grams. At that point, nitrogen's gone, hydrogen is left over. So the nitrogen is limiting the production. Now, as far as the percentage yield goes, on paper, whenever we do a mass-mass problem like this, that is our theoretical yield. So in theory, 17 grams of hydrogen is how much we could, 17 grams of ammonia is how much we could make. Does that happen in the lab? No. You're not going to get a 100% yield. And you can see in the problem up there, it tells us that 16.1 grams of ammonia actually form. And so we can calculate the percentage yield. It's just like a test. If the test is worth 80 points and you get 70, it's 70 divided by 80, and then you multiply by 100 to get your percent on a test. And so that's what we see here. 16.1 grams is what we actually got. That was from the problem above. 17 grams is our theoretical yield that we calculated. And so when we multiply by 100, then we have a 94.7% yield. All right, so that's the example explained to you a little bit from the book. Let's look at another one here. Here we have, as it says in your notes packet, determine the limiting reactant, the theoretical yield, and the percentage yield if 16.1 grams of bromine are mixed with 8.42 grams of chlorine. And when that happens, we get 21.1 grams of the bromine chloride to form. So what you need to do is you need to do your two mass-mass problems. There's 16.1 grams of bromine, and you want to know how many grams of product can you make from that. Then you have 8.42 grams of chlorine, and again, you want to know how many grams of product can you make from that. So you do those two mass-mass problems. Whichever one has the smaller answer is our limiting reactant, and then we can use that piece of information to find the percentage yield. So pause the video, give it your best shot, and then I'll show you the answer here. So either way you do the mass-mass problem, you can see that if I use all 16.1 grams of bromine, I'm going to come out with 23.3 grams of product. If I use all 8.42 grams of chlorine, then I'm going to come out with 27.4 grams of product. So the lower number is the 23.3 grams. And so because of that, bromine is my limiting reactant. The percent yield, then, I take my actual yield, 21.1 grams, which was in the product, or I'm sorry, in the problem, 21.1 grams, and then I use the 23.3 grams for my theoretical yield that I calculated, and I get the 90.6%. Let me just make these pages a little bigger if you want to pause the video. This is the two mass problems using the long dimensional analysis way. This is the two mass problems using the shorter method. There's the first one. There's the second one. And then there is the percent yield blown up. So pause the video if you need to catch any of those. Now, on the back of the stoichiometry review paper I gave you, there is one more percent yield and limiting reactant question. So if you want to check that one out, pause the video and I will show you that answer here. Okay, so again, this is on the back of your stoichiometry review paper, and now here we have lithium and fluorine making lithium fluoride, and we want to know the limiting reactant, the theoretical yield, and the percent yield if 44 grams of fluorine are going to be mixed with 18.5 grams of lithium and forming 55.5 grams of the lithium fluoride. It's worded a little different here, but it is the same problem. So again, the two mass problems. This is the dimensional analysis way. So I have my 18.5 grams of lithium. If I use all that, then I can make 69.4 grams of the lithium fluoride. 44 grams of fluorine. If I use all that, I can make 60 grams of the lithium fluoride. Here it is in the short version. Again, 18.5 grams of lithium can make the 69.4 grams of the lithium fluoride. 44 grams of fluorine can make the 60 grams of lithium fluoride. So because 60 is the lower number, fluorine, F2, is my limiting reactant. I use that answer, 60 grams, that is my theoretical yield. And as I said, the problem told me 55.5 grams. My actual yield was in the problem. And so my percent yield is 92.5%. All right, hope that helps with this, and I hope your limiting reactant lab goes well. Later.